Hey guys, today let's talk about the binomial theorem. The binomial theorem is just a method of expanding a binomial expression. First of all, let's recognize what are binomials. So first of all, a binomial is just a polynomial with two terms. For example, x plus 3 is a binomial. In this expression, we have a term of x and we have a term of 3, and both of them are unlike terms, meaning that they cannot be combined. Similarly, other expressions such as x squared plus x are binomials because they are unlike terms. Or we can have y plus abc. abc is still a term. And some other things are like, for example, y plus z is still a binomial. Even though it looks like there's 3 terms, we can actually simplify it into y plus 2z. Or we can have x plus 2 it's just equal to x plus 4. So these are binomials. And what's not a binomial? Well, for example, 4 plus 5 is not a binomial because it can be rewritten to 9. Because remember that we need 2 unlike terms for a binomial. X squared is not a binomial because it only has 1 term. Although it's squared, and it looks like it's a binomial because it's equal to x multiplied by x. Remember that we need 2 unlike terms. And similarly, y plus z plus x is not a binomial because it has 3 terms. So it's actually a trinomial, so we won't be getting into that. So let's talk about the binomial expansion. So basically, remember that in your basic math classes, you might have done something like this, x plus 2 squared. So we will just expand it, so it's x plus 2 times x plus 2. Then we will use the distributive properties to distribute x to both x and 2x. So we have x squared plus 2x. And then we distribute the 2 to these 2 terms. So we have plus 2x plus 4. So we have x squared plus 4x plus 4. Great. So we can just expand them out and distribute them and multiply them one by one when it's a binomial with a smaller power over here. However, if the powers become too large, the original method becomes less convenient and it becomes a lot more tedious. So now we have this binomial expression. While this may seem daunting, let's break it up together. And so this just a and b are just 2 of the unlike terms in a binomial, and this sigma just means sum. So it's the sum of k from 0, its lower bound, to its upper bound k. And this one is just a combination symbol. It just means and choose k. And it represents the coefficient of our binomial. For example, these are all coefficients, and this has a coefficient of 1. So we have the first term raised to a power and the second term raised to the other power. While this may seem abstract, let's practice it together. For example, let's expand this thing together. So we can first write it in the binomial theorem form. So it's just the sum from k equals to 0, and it's raised to a power of 3, so n is equal to 3. Then we have 3 choose k, a to n minus k, and bk. So let's substitute it in one by one. So when k is equal to 0, we have 3 choose 0, a, so it's 3 minus 0, b to the 0. b to the 0 is just equal to 1. So it becomes, and 3 choose 0 is equal to 1. So it's 1a to the power of 3. b to the 0 is just equal to 1. So this is just equal to a to the third. Then we have 3 choose 1a, 2 minus 1b. So this is 3a squared times b. And we have 3 choose 2, a, b to the 1 equal to 3. And lastly, we have 3 choose 3 of 3. Wait. B. So at last, after the binomial expression, we have a squared plus 3a squared b plus 3ab squared plus b cubed. Notice that there is symmetry because this coefficient is equal to this coefficient and this coefficient is equal to this coefficient because 3 choose 1 is the same as 3 choose 2. For example, if I had 3 apples and I had to choose 1, I will have 3 options. And if I had to choose 2, isn't it just a similar if I had 3 balls and I wanted to choose 2, isn't it just the same as choosing 1 that is not going to be chosen? So this explains for the symmetry, and it means that we have to do less calculations, which is great. Now let's do another exercise together, and feel free to pause this video and solve it yourself first. Okay, welcome back everybody. So let's start to solve this equation. Firstly, we can just write out the formula so that we can remind ourselves what are we going to do. Over here, the exponent is 6, so n is equal to 6k. Or we can just write 6 minus k times b to the k. Okay, let's start. With the binomials system, we know that 6 choose 0 is just 1. So the first term is equal to we can just substitute in a for x and b to negative 2y. So it's just equal to x to the 6. Now our second term, 6 choose 1 is equal to 6. And now we have x to the 5th power. And we have negative 2y to the 1st power. So this is equal to negative 12x5 times y. Then we have 6 choose 2. And we know that 6 choose 2 is equal to 15. So we have 15x to the 4th, negative 2y squared, which is just equal to 60x to the 4y squared. And then the fourth term, we have 6 choose 3. So this is 20x cubed, negative 2y cubed. And over here, 2 cubed is 8. So we have 20 times 8, which is a negative, and 60x cubed y cubed. Then we have 6 choose 4, and 6 choose 4 is just the same as 6 choose 2. So by symmetry, the coefficient is 15. We have 15x squared, negative 2y to the power of 4. So we have 240x squared y to the power of 4. Then by symmetry, this coefficient of 6 choose 5 is the same as 6 choose 1, so it's x 2y, negative 2y to the 5th. So we have negative 192x y 5th. And the last one has a coefficient of 1 due to symmetry. 6 choose 0 is the same as 6 choose 6. X to the power of 0 is just equal to 1. And negative 2y to the 6th power is 64y 6. So in conclusion, we have the answer of x to the power of 6 plus 12x to the 5y plus 60x to the power of 4y squared minus 160 x cubed y cubed plus 240x squared y to the power of 4 minus 192x times y to the power of 5 plus 64 minus 6. And notice how this is much more efficient than writing this for 6 times and distributing it again and again. So this is the binomial theorem. Thank you so much for watching, and feel free to ask a question in the comments if you are still confused.